Okay, this is my capstone project for managing machine learning projects. My project topic is a system that allows users to um, measure themselves as they're sleeping in order to identify the optimal time to wake up such that they might remember their dreams. And ultimately, the goal of this system would be to improve dream recall. And so it's about using machine learning on biometric data and behavioral data to get this improvement in recall. And so, walking through the logic of evaluating this opportunity, um, the problem of being unable to remember your dreams and the opportunity that's granted when you improve your ability to remember your dreams could be thought of through the lens of these five uh, parameters. There's the affected population. There's likely millions of people worldwide that struggle to remember their dreams, if not more than that. The significance of this, if you're able to remember your dreams more effectively, that can grant you deeper personal insight and the ability to navigate through a journey of self therapy. There are existing solutions such as dream journaling, but these can be difficult to maintain. There are other solutions out there as well, and they also likewise have their drawbacks. The correlation between the problem and the impact of insight and wellness is that increased self awareness can be helpful in improving behavioral and physiological changes that result from that. And you can enhance your sleep by cultivating a better relationship with your sleeping life, including dreaming. And ultimately, the practicality, if there's room to improve dream recall within the physiological bounds of your life, then that's something that can improve these other dimensions, such as mental well-being, physiological well-being like sleep, and ultimately self-understanding. So how is this solved today? There's a number of different methods, but calling out three, there's dream journaling. There's a supplement called galantamine that has been shown to improve dream recall and dream vividness. And then there are techniques such as mnemonic induction of lucid dreaming, which is really intention setting before going to sleep, and other techniques that are used to improve the ability of people to recall their dreams and ultimately achieve lucid dreaming. Um, and so, if we think about those solutions and how we might converge upon a possible solution today, we could take those techniques and then use it in conjunction with a wearable device that's running a machine learning system built to help users improve their dream recall. And none of those other techniques, some of them or all of them in conjunction, might be used by the user to help them achieve better recall over time. And so maybe they want to see if dream journaling actually helps them remember their dreams. Maybe they want to see if mild or galantamine helps. Moreover, maybe the system's default assistive setting is about identifying the right time to wake you up. What's the right phase of sleep to wake you up from? When during that phase of sleep? Those are all things that this convergence of these different approaches could help solve this problem from. And then there's the technical feasibility, and there's quite a few steps here, but you want to define the objectives. So, really shape the problem, how you might solve it, identify the technical requirements. The image showed a wearable device such as an Oura Ring or an Apple Watch, the software on there. Assess available resources. So, do you have the human capital and the materials to jump into this project? There's the initial research around sleep patterns and correlations with dreaming, psychological phenomena. There's a technology option assessment, so what platform, hardware, and software might you use? And then there's the proof of concept that comes from there. Then, as you start to validate this proof of concept, you'll want to start considering risks and constraints. There could be regulatory and privacy and health related, and those are all things, along with system constraints such as data or concept drift, which we'll get into. And then, of course, there's estimating the allocation of resource and costs associated with the project, ultimately the scalability and future growth of this project into a possible business. And then performing an analysis, reviewing document findings, recommendation, and then reviewing all of this content and making a decision if this is something worth moving forward and translating into a business, or bringing into an existing business. So with that said, the CRISP DM business understanding phase is a way of analyzing if a problem can or ought to be solved by data science and machine learning techniques specifically. So framing this problem, people struggle to remember their dreams when they wake up, even if they have the intention of remembering them. This is a problem for folks that want to understand themselves better. For those that don't care about their dreams, this isn't necessarily a problem, but for those that do, this would be considered a problem. And if they want to get to know themselves and what's going on, that is the result of their subconscious working, the part of themselves that they cannot control, then dreams are a good way to do that. So this is a way to investigate yourself more deeply. And memory is a necessary component of personal dreaming. So this is sort of a relatively arbitrary definition of success, and maybe one that's quite, bold, I suppose. But I think it'd be, quite a success if a user is able to leverage the system and improve their ability to remember their dreams by 50%. So if they remember their dreams 2 nights out of the week, then this would increase their ability to remember dreams to at least 3 nights a week, and then the solution would be considered a success. So outcome metrics. These are some hard numbers that we would get associated with the changes that the user would want to track. And so the key outcome is dream recall, a 50% increase in the frequency of remembered dreams. It would be a good improvement. And then there's user satisfaction. This measures how satisfied users are with their ability to remember their dreams, and could be assessed through user surveys or interviews. So there's increase in dream recall. And then there's improved quality of sleep. The solution is actually helping with sleep quality, then this would be something that would be worth tracking. And this could be actually measured using devices that the user is wearing while sleeping. And then there's output metrics. So usage, retention, if the user would recommend this application. So surveys could be given to the user before and after. And then prompt response times are kind of a possible index of how well the user can remember their dreams. Faster response times are correlating to an improved memory of dreams. Some other metrics are, dream report frequency. How frequently are users able to provide a dream report, correlating to, of course, the number of recall moments that they have. There's dream report detail, how detailed and at length can a user give a dream report. Consistency, so the consistency night over night, say that you have a streak of 5 remembered nights in a row. There's biological data that corresponds to sleep and dreaming, and then there's user feedback on their experience with the system. Right, so all some output metrics. Some relevant factors to consider with this opportunity is user segmentation. Different users might have different needs and capabilities that correspond to things like age, lifestyle, sleep habits, medical conditions, etc. And then there's competitive analysis. It'd be good to understand the market and how any solution, whether it's a medication or a technique, is fitting into the ecosystem. And how users might have an experience with some of those things. And then ultimately thinking about how this solution is different from those. Of course, when it comes to healthcare type of applications, data, privacy, and security ought to be considered, and the regulatory environment in which the product is sold and used needs to be considered as well. So the system architecture that I think from the machine learning standpoint ought to be considered, I think this should be an edge system that leverages offline learning but online predictions. And so the reasoning for this is that if it's edge, it's really a wearable, or a machine learning system that leverages hardware that is at the site of where the prediction needs to happen, right? And this is useful for user privacy as well, which is an important consideration here. But it's going to keep the latency relatively low and no need for continuous connectivity, which could all be relevant when a user is sleeping, right? Offline learning. So foundational model training, even though everyone's different, ultimately, you'd want to kind of train this model to be able to recognize sleep patterns based on standard behavior of how people move through the phases of sleep. There's implementation and evaluation to consider, and offline learning is often an easier avenue there. And then managed adaptation, because the foundational training is going to be kind of crucial to the base of the model. You can ultimately manage the way that the model evolves. And then online predictions, real-time feedback. So the user is awoken by the system, right? Because the system is able to identify when to wake the user up. The wearable sends a signal to the little alarm clock or the phone or whatever and wakes the user when they're most likely to be dreaming. Nightly adaptation, maybe within the night. The system recognizes that it has a true positive, and so it within that night starts to adjust itself so that it signals again to awake the user for the true positive, so that they might return another dream journal recording. And then online prediction, model monitoring might allow the system administrators or the user themselves to give feedback right away to the system. As the system is producing real-time predictions, you can give feedback to the system saying this prediction is off, right? You woke me up and I don't remember my dream and it's late. Don't do this again, right? There's the ability to give the system that type of feedback. So there are potential risks in production of both data and concept drift variety. So data drift could come from irregular sleep schedules, changes in device usage, and then the system device degrading. And all of that could actually impact the distribution of data. And then concept drift change could be caused by lifestyle changes, the user aging, and then the long-term effect of some of these techniques. So over time, the ways in which they dream might change because, say, they're taking a supplement, or say that they're waking up at different times to they're very early in the morning or something, so that they might remember their dreams more. These could have a type of feedback on their sleep schedule that changes the ways in which they're sleeping and dreaming. And so identifying and mitigating these risks include regularly monitoring, creating a feedback loop, allowing users to give input, regularly retraining the model, keep it calibrated and accurate, building a drift detection mechanism, and triggering updates or alerts if a significant enough drift is detected. So concluding remarks, let's summarize really quick. The opportunity eval problem and opportunity, people struggle to remember their dreams, which hampers self-understanding. A machine learning solution can aid in enhancing dream recall and enable personal insight. Business understanding, we want to improve a user's dream recall frequency by at least 50%. As a byproduct, maybe help with self-understanding and satisfaction, and possibly even sleep quality. We'll measure performance by looking at the usage frequency of the system, retention rate of users, the recommendation rate, would they recommend the system, The prompt response time, are they able to give a dream report upon a prompt quickly? How often are they reporting their dreams? The detail, consistency, and quality of sleep data, all indexes of the system's performance. Validation plan would include conducting both sham and real tests to establish baseline and post implementation measures. User feedback would come through surveys and interviews to assess user satisfaction and system impact. Right, these are ways that we would validate that the system is working and that the people that are using the system are satisfied with its functionality. Machine learning system design, the architecture would be at the edge for computing, and offline learning for foundational training, and then online prediction for real time assistance. The integration of the techniques in the system would ultimately amount in the solution. And then there's the risks of data drift and concept drift due to sleep schedule changes, device degradation, and then on the concept side, lifestyle changes or aging, things along those lines. Thank you so much, and sleep well.